So today I'm continuing with yesterday's topic, which is the fundamental theorem of arithmetic. I'm just doing some straightforward examples. It should take no longer than 2 to 3 minutes. All right, so my first number that I'm going to do my prime factorization for is 48. And remember, all you have to do is know some multiplication facts, maybe some division facts. So whichever two factors you can think of that can get you 48, you just start with that. The first one that came to my mind was 4 times 12. Now, I further factor this one into prime numbers, 2 times 2, so those are done. Now, over here, I have 2 times 6 for 12, but for the 6, I have 2 times 3. So if I look at my prime factorization tree, how many do I have? 1, 2, 3, 4. I have 4 2s. 2 times 2 times 2 times 2 times 3. And there's my prime factorization for the number 48. 2 times 2 times 2 times 2 times 3. All right, what if we look at the number 90? First thing that comes to my mind is 9 times 10. Now, 9 can further factor into a 3 times 3. And this 10, 2 times 5. And there's all of my prime numbers. So I have a 2 times 3 times 3 times 5. And that's the whole thing right there. 2 times 3 times 3 times 5. And there it is. All right, the number 60. 6 times 10. This is a 2 times 3 for the 6, and for the 10, I have a 2 times 5. So here I have a 2 times 2 times 3 times 5. Normally when I list out my factors at the end, I put them in numerical order. So 60, this is for 60, there's my 90, there's my 48. And all of this is just prime factorization because you're left with nothing but prime numbers here. All right, so 180, 3 times 60. 6 times 10. That's a 2 times a 3. And that's a 2 times a 5. So what are we looking at? We're looking at a 2 times 2 times 3 times 3 times 5. That's the full prime factorization for 180. 2 times 2 times 3 times 3 times 5. All right, so 249. A key fact here, I'm not sure if you all knew this, but if you look at each one of these digits separately and just added them up, like 2 plus 4 plus 9, what you'll get is 15, right? And if your total is something that is divisible by 3, then that means that number is divisible by 3. So in other words, because I added these 3 digits up and got 15, I know 3 can go into this number. So 3 goes into there 83 times. And that's it. 83 happens to be a prime number. And that's all there is to it. So all factor trees won't spread out into a whole bunch of digits like this one did. Sometimes that's all you get. And it can happen. Just remember, whatever you're left with has to be prime numbers. And so that's the only examples I really wanted to go over today. I remember doing these around 3rd and 4th grade. I didn't really understand why, but now I kind of get it. But cool skill to know because you can use them for other things.